So one common type of a continuous distribution is the uniform distribution. Now, I have an example here showing you it's using X as being time in minutes. You notice between A and B, the height does not change at all. So what that's telling me is that it's uniform. So let's say that A was 5 and B was 10 let's say at 8, that probability wouldn't change. Okay, so how do I find what does the area of the rectangle have to be if this is a probability distribution? And hopefully you think, well, if everything's in there, it has to be 1. So how did I come up with this height being 1 divided by b minus a? Well, we know that this width here is how wide it is. That's the range, and that's b minus a. Okay, so that's how far it is between these two. If I know that the area to be a valid probability distribution has to be 1, what do I have to multiply by? In other words, by this height to get there. And hopefully you think, well, by the reciprocal. And there you go. B minus a times 1 over b minus a. The b minus a's would cancel, and you end up with 1. You do not need, we're not going to go over how these are derived, but you can just use them. So the expected value is going to be at the center. It's going to be right here. So you just take a plus b or b plus a and divide it by 2. So there's our expected value. The variance is going to be, you're going to take b minus a, square it, and divide by 12. And consequently, to get the standard deviation, you would take the square root of that variance. Once again, we're not going to come with derivation. This is just something I would make sure you have on your summary cheat sheet if you do one for the exam. So let's do an example of a uniform distribution. First of all, you may be like, well, how would I know it's uniform? You're going to need to be told that it's a uniform distribution. Please pause the video and read over example 9.2 and then come back. Okay, so we're told that it's uniformly distributed, and I'm assuming you've read this, so I'm not going to go through all the details. The first thing I like to do, honestly, is to draw a picture. It doesn't take long, and it helps me to visualize what's going on. And I'm told that we're looking at time in minutes. I like to label my axes. You should label your axes. That's the best way to do it. And we know it's going to be between 15 and 45 minutes. And we're told that it's uniformly distributed. So that height, in theory, is it's perfectly straight across the top. I know that this height, so that area under that curve is 1, has to be 1 over b minus a. So in other words, 1 over 30, because 45 minus 15 is 30. Now it asks me, what's the probability that it will take exactly 22 minutes to service a randomly selected plane? Well, I'm going to use t as my random variable. T is going to be the time to service the plane. Okay. Probability that t is exactly 22. Hopefully you think, well, it's exactly 22. It has to be 0. So what if you struggle with that you're just like, I don't see it. Remember that area under the curve is going to be the probability. So let's find that area. So I'm going to do the height times the base. And let's see, the base is 22 minus 22. And I get, oh, that's just 0. So that's another way to look at it if you are struggling with that idea of the area of a line being 0. You can see it right there. What's the probability that it will take less than 20 minutes to service a randomly selected plane? Now, you don't have to redraw it perfectly, but you may want to take a minute and say, okay, 15 to 45. No, this is 1 over 30. And I'm looking at 20 minutes. It doesn't have to be to scale, but I want less than 20 minutes. A lot of times that will help you just to see what area are you looking at. So that probability that t is less than 20 minutes is going to be the height times the base. and that'll give me 1/6. Alrighty, cool. What's the probability that it'll take more than 30 minutes? Well, let's see. Here I want that it's going to take more than 30. Even simpler if you want to just do, well, I know my height is 1/30. I know I'm going 15 to 45 and I want greater than 30. So this area here. You may say, well, wait a minute, that's right in the middle, so it's got to be 50%. But if you're not sure, or if you're on an exam, I would suggest taking a moment and doing the calculation. The height is 1/30. The base is going to be 45 minus 30. And I end up with 1/2. Perfect. Here it asks, what's the 40th percentile? Now, when it says 40th percentile, it wants to know, we've got 15 to 45 again, 1/30. It knows that the area under that curve is 0.4 here that we're interested in, but we don't know at what time that's going to happen. And I'm going to call that time K. So when does the 40th percentile happen is effectively what it's asking. Less than K, so that we get the 40th percentile. Okay, can I find that area under that curve? Sure. I know I'm going to take the height times the base, which is K minus 15. This is why I suggest doing a little, do a little quick drawing, because sometimes students will not be sure whether I do like 15 minus K or K minus 15, and it does make a difference. And we know that area has to equal 0.4. Because that's what we're told here, that area being the probability. That probability is 0.4. Multiply both sides by 30, add 15, and you're going to get K equals 27 minutes. Good to label the units when you have them. Now it's asking 90% of planes will be turned around in about how much time? Or in how much time? Now here we're doing 90%. I've got 45, and we're going to go all the way up to 90. And I'll call this one M just to make sure that we all see it. I'm not going to write this one out, but I would suggest practicing this, and you should get 42 minutes. Now, what's the expected turnaround time? Don't make this hard. Say, okay, I know there's a formula. I take the two ends, I add them together, and I divide by 2, and I get 30 minutes. It's symmetric, so I would expect it to be right in the middle. Expected being that mean average time. And the standard deviation, we're going to take the 45, the one far end minus 15. We square it, divide by 12, and then we take the square root. And we'll get 8.66 minutes. So that's an example of uniform distribution and how we would use it.